Hey, what's up, everyone? So, if you're working with ASP.NET Core, you probably feel pretty good about security, right? I mean, the framework gives you so much stuff right out of the box. But, and this is a big but, that feeling can be a trap. A lot of us get this false sense of security. So today, we're going to pull back the curtain on some of the most common and honestly kind of scary vulnerabilities that a ton of developers miss. The kind of stuff that can turn a good day into a really, really bad one. All right, so let's just get right to it. I want you to really think about this for a second. You fire up a new project, you use the default templates, you follow all the Microsoft guides. So your app is secure, right? I mean, it should be. The thing is, the framework just gives you a box of really sharp tools. It doesn't stop you from using them wrong. And as you're about to see, even the foundation, the core framework itself, isn't always as solid as we think. So what's this number? 9.9? This isn't just some random number. This is a CVSS score. Think of it as a security vulnerability Richter scale. 10 is the absolute worst, so 9.9 is, well, it's pretty much catastrophic. This was a real critical vulnerability found in Kestrel, the web server that powers pretty much every ASP.NET Core app. This bug literally let attackers sneak malicious requests right past security, sometimes even bypassing authentication entirely. And that should be a huge wake-up call, right? If the bedrock itself can crack, you have to wonder about the security of the house you built on it. All right, so that brings us to our first big topic, the front door. We're talking about the request pipeline here. And this is where things can go wrong before your own code even gets a chance to see what's happening. It's kind of like you've spent all this time installing fancy locks on your windows, but you forgot to lock the front door. And one of the sneakiest mistakes you can make is getting your middleware order wrong. What makes this so dangerous is that it doesn't blow up. Your app won't crash, you won't see any exceptions in your logs, nothing. It just fails silently, leaving a gaping hole for attackers to walk right through. It's seriously one of the scariest types of bugs because you have no idea it's even there. Okay, let's look at some code. This is a classic mistake. On the left, you see the vulnerable way. We're calling use authentication and use authorization before use routing. And, at first glance, that seems to make sense, right? Figure out who the user is before you do anything else. But it's totally wrong. Think about it. How can you check if a user is authorized for something if you don't even know what they're trying to access yet? You can't. That's why the correct way, on the right, is to call use routing first. That way, the app knows the endpoint, it can look up its security rules, and then it can apply authentication and authorization properly. And this is really the terrifying part. You're not going to find this with your unit tests. Your QA team probably won't find it. Why? Because from the outside, everything looks like it's working perfectly. The only time you'll discover this flaw is when you're reading a security incident report about your own application. Okay, next up, let's talk about identity, and more specifically about one of the biggest mistakes I see developers make, trusting the client. I call this the client-side trust fallacy, because you should absolutely never ever trust anything that comes from a user's browser. You see this a lot in frameworks like Blazor or WebAssembly. It's so easy, right? You just add an authorized attribute here, you check a user's role there, you write a little if statement to hide the admin button, and poof, it feels secure. But here's the reality check. All that client-side code, that's just for making the UI look nice. It is not security. It's just a polite suggestion. And I mean, look how ridiculously easy this is for an attacker. They don't need to be some super hacker. All they have to do is open the developer tools in their browser, F12, find the little piece of JavaScript code that says admin equals false, change it to true, and bam, the admin button magically appears. And if your backend API isn't doing its own checks, that button is now going to work. Game over. So here's how you actually fix it. The code on the left, the Blazor component with the authorized attribute, that's just window dressing. It's a suggestion. The real lock, the actual security, is on the right. It's the authorized attribute on your server-side API controller. Every single time your front end makes a call to the backend, that backend code has to re-verify everything from a trusted source, like the JWT. It can't trust anything the client says about who they are. And speaking of JWTs, they aren't magic bullets either. You can mess them up. One of the most famous attacks is called algorithm confusion. It's clever, I'll give them that. An attacker takes a token that was signed with, say, RS-256, which uses a public/private key pair. They grab the public key, which is, public, and they change the algorithm in the token's header to HS-256, which uses a single shared secret. Then they re-sign the token using the public key as the secret. Now, if your server isn't configured to say, hey, I only accept RS-256, it'll see the HS-256, use the public key to validate it, and it will work. The attacker just forged a perfectly valid token. Okay, our next category of vulnerabilities is what I like to call the Trojan horse attacks. This is where the danger isn't coming from the outside. It's something you've willingly pulled inside your application's walls, not realizing it's packed with malicious intent. And a huge one here is insecure deserialization. Listen, if you see binary formatter anywhere in your codebase, you need to treat it like a 5-alarm fire. This thing is so dangerous. An attacker can create a specially crafted piece of data that when your app tries to deserialize it, doesn't just turn into an object, it executes code on your server. We're not talking about stealing some data here. We're talking about giving an attacker a command line on your production machine. There's a reason Microsoft marked it as obsolete. Get rid of it now.
Here's another really subtle but nasty one, mass assignment, sometimes called overposting. So look at the code on the left. Your API endpoint to update a user profile just accepts your big, rich user domain model. Seems convenient, right? But what if an attacker just adds isAdmin true to the JSON payload they sent you? Well, the ASP.NET Core model binder will see that, see the isAdmin property on your user object, and just set it. It doesn't know any better. And just like that, the attacker is an admin. The fix, as you see on the right, is to never ever bind directly to your domain models. Instead, you create a dedicated data transfer object, or DTO, that has only the properties you want the user to be able to change, like their email address or name.
All right, this next one, this question right here, gets to the absolute core of what the OWASP Top 10 lists as the #1 API vulnerability today. It's called Broken Object Level Authorization, or BOLA. So your code checks that the user's logged in. Great. It checks that they have the Can View Invoices permission. Perfect. But you miss the most critical question of all. So check this out. On the left, the vulnerable code. The API gets a request for /API/invoices/123. It finds invoiced 123 and sends it back. The problem? The attacker can just change the URL to /API/invoices/124, then 125, then 126, and just walk through all of your customers' data. The fix is so simple, but so critical. Look at the code on the right. After we fetch the invoice from the database, we add one more check. Does this invoice actually belong to the person who's logged in right now? If not, we immediately shut them down. It's that one extra if statement that separates a secure app from a massive data breach. Okay, I know we've just gone through a lot of kind of scary scenarios, but look, the point isn't to make you paranoid. It's to make you prepared. So let's turn all this knowledge into action. Here's a quick checklist you can literally take and use to audit your own applications today. First, let's talk pipeline and config. Number 1, open up program.cs and audit your middleware order. Make absolutely sure use routing is called before use authentication and use authorization. Next, check your course policies. If you see allow any origin and allow credentials used together, that's a huge red flag. Fix it. And finally, please double check that you're not shipping the developer exception page to production. That's just giving attackers a roadmap to your code. All right, on to auth and identity. I'm going to say it one more time because it's that important. All authorization decisions must happen on the server. Full stop. The client cannot be trusted. While you're at it, look at your JWT validation logic. Make sure you are explicitly telling it which signing algorithms are allowed. And finally, get your user's claims and permissions from the validated token, not from some payload the client sent up. And last but not least, data handling. Your homework for today, do a global search in your solution for binary formatter. If you find it, your mission is to eradicate it. Second, go through your API controllers and make sure you're using DTOs for any incoming data to prevent mass assignment. And third, for every single endpoint that looks something like get by ID, add that BOLA check to make sure the user owns the thing they're asking for. So here's the bottom line. Security isn't just a feature on a checklist that you can mark as done. It's a continuous practice. It's a mindset. ASP.NET Core gives you an amazing, powerful set of tools to build secure applications, but it assumes you're going to use them correctly. So I'll leave you with this question to think about as you go back to your code. Which one of these mistakes is hiding in your app right now?
If this helped you tighten up your app, hit that like button, share this video with another developer, and subscribe to The Curious Dev for more deep dive tutorials like this.